Hello friends, so here is another question on equation of motion. So here it is given that a police officer in a car is chasing a thief in a straight road, and the police car is going at its maximum speed v, small v. The thief then rides on the motorcycle of his accomplice, another of one of his friends who was waiting on the side of the road, and exactly at that point the police car is at a distance small d away from the thief. From the point where the thief rides the motorcycle, at that point the police car is at a distance d away. Okay. The motorcycle starts with a constant acceleration a, small a, and we have been asked to prove or to show that the thief will get caught if the velocity of the police car is greater than equal to root over of 2AD, that is v is greater than equal to root over of 2AD, where a is the acceleration of the motorcycle, the thief's motorcycle, and d is the separation, the initial separation distance between the police car and the thief. Okay, so let us try to visualize the whole situation. Okay, convert it into a diagram. First step in solving any question, read the question carefully, then understand it, then convert it into a diagram, a visual representation, so that you can imagine, you can figure out what is happening. So it has been given that a police car okay, this is the police car, we'll call it PC. It is moving with a velocity, a uniform velocity v, constant velocity v. It is chasing a thief. Okay, this is the thief. Now while it is chasing the thief hitches ride with one of his accomplice on a motorcycle. Okay, so it is like this. Okay, it doesn't look like a motorcycle, but still, okay, this, it's a motorcycle. Okay, hitches the ride with a motorcycle on this. So while at this point and this point, this gap is d, the separation is d. The point where the thief rides on the motorcycle, this point and this point, the separation distance is d, and the motorcycle is getting accelerated at the rate of a. Okay, this much. Now we have to prove that the thief will get caught if the police car's velocity is greater than equal to root over of 2AD, where a is the acceleration of the thief's motorcycle and d is the separation distance. Okay, let us assume that after some time t, okay, after some time t, the police car catches up with the thief's motorcycle. Okay, and the two thieves are nabbed. Okay, at this point, it is after a time interval t seconds at this point. So here, from this point to this point, okay, from this point to this point, the distance which is traveled is, taking into consideration the acceleration of the thief's motorcycle A, the distance traveled by them is equal to 1 half a t square, because the initial velocity of the thief's motorcycle is equal to 0. Initial velocity is 0. So the distance traveled from this point to this point, okay, that is equal to simply ut plus half at square. So it is 0 t plus half at square, which is simply half at square. Okay, this point to this point, the distance is half at square. Okay, this. Now if the police car has to catch the thief at exactly this point after t seconds, then in those t seconds, okay, in those t seconds, it has to cover first from here to here, that is this d, okay, this much, and then this much, half at square, it has to cover. So total distance covered by the police car is d plus half at square. This is the total distance which has to be covered by the police car. The police car is moving with a constant uniform velocity v, okay, and it has to cover this much distance d plus half at square in t seconds. So if we take into consideration the constant uniform velocity of the police car, then in t seconds it will cover a distance of v into t, this much distance, okay, covered by the police car in t seconds. To catch the thief, it has to cover d plus 1 half at square. So it means both of them are equal. Vt is equal to d plus half at square. Okay, so it will come in the form of a quadratic equation. So what we'll do, we'll write that implies 1 half at square minus Vt plus d is equal to 0. Okay, that implies multiplying 2 throughout, it will be at square minus 2 Vt plus 2d is equal to 0. So it is in the form of ax square plus bx plus c equals to 0. So we have to solve for x. So here we will be solving for t, because that is the parameter which is we want to determine. So it will be t is equal to minus b, okay, we know that x is equal to minus b plus minus root over of b square minus 4ac by 2a. So here, taking that into consideration, it is minus b, which is minus of minus 2v plus minus b square, that is minus 2v square minus 4ac, that is 4a into 2d. Let us bring this to the side so that we have some space. Okay, this minus 4 into 2ad to t. Okay, this much 4a into 2d, sorry, 4a into 2d. Okay, 4a into 2d. This is 4 into a into 2t by 2a. This. Okay. So here we have that is equal to 2v plus minus 4v square minus 8ad, or we can write it as minus 4 into 2ad. We'll write it in 4 multiplied form, that 2a. That implies if we bring the 4 outside, it will be 2v plus minus 2 into root over of 2v whole square. Okay, this will be v square. Okay, v square minus 2ad by 2a. So here 2 will get cancelled again. It will be in the form of 2 into v plus minus root over of v square minus 2ad by 2a. 2 will get cancelled. This is the value of t. Now we know that t should always be real and positive. Okay, time should always be real and positive value. Real and positive value. Now this is possible only when v square minus 2ad, this portion, okay, this portion v square minus 2ad, that is greater than or equal to 0, or we can write it as v square is greater than or equal to 2ad, or v is greater than or equal to root over of 2ad. This is the condition which we want, which was asked here. This greater than or equal to, same. Okay, this. So this was a very good question, a very interesting question, where we had to use our imagination to visualize the whole thing. So accurately converting the question into a proper diagram is very important. So here first we we convert it into a proper diagram. A police car traveling with velocity v, a thief hitching a ride with one of his accomplices. At that point the separation distance is d. They are caught after a time interval of t seconds at this point. So in order to do that, in those t seconds, the police car has to cover a total distance of this d first, and then the 1/2 at square, which is done by the thief in those t seconds, because it is moving with a acceleration a. Okay, constant uniform acceleration a. So here we just convert it into a quadratic equation. Vt is equal to d plus 1/2 at square, and then we used the basic quadratic equation formula to get at this result. Okay.